Welcome everyone. It's great to be here today at the first JupyterCon conference here in New York City. And I'm really thrilled to be able to talk to you today about the Jupyter Notebook and other front ends, Jupyter Frontends, with Kelley here. Both Kyle and I have been working on the project for many years, and it's again great to be here. A quick outline of what we'll be talking about today. And the focus really here is giving you a semi-historical perspective of how we got to where we are with the Jupyter Notebook, also looking forward, and in particular thinking about what are the key ideas of the Jupyter architecture as it relates to building user interfaces for interactive computing. Before we get started with the actual talk, I wanted to mention an opportunity for you to participate in our project. We have both today and tomorrow in-person user testing. If you keep going down this hall all the way to the end, we have a number of people from the core project and also in collaboration with Bloomberg doing user experience testing. We've got 4 different activities all day today, tomorrow. Would love it if you would come and help us with that. And we'd love to get a diverse range of participants. So if you've never used Jupyter before, if you're a Jupyter expert, or anywhere in between, it would be fantastic. You can either go to the bit.ly link down at the bottom there, or just drop by even. We've got 4 different stations and a lot of capacity. So I want to begin with thinking about what do we mean by interactive computing? And here's a rough take at a definition of what we mean. An interactive computation is a persistent computer program that runs with a human in the loop, where the primary mode of steering the program is through the human iteratively writing and running blocks of code and looking at the result. Many programs are interactive, so Microsoft Word, Excel, web browsers. In a sense, there's a human in the loop there steering the course of the program. The key difference in this context, in the Jupyter context, in data science and scientific computing, is that the way that we're steering the computation is through typing source code and handing it off to the program to be run. And so that's very different from a program like Excel, which in many ways does similar types of things that we often do in Python or R or Julia. But that's sort of the emphasis in this context. And what this means is that interactive computing necessarily is human-centered. Right? And so when we think about user interfaces, those are really the sit between the user, the human user, and the computer. And I'd like to break down this idea of interactive computing into sort of the different parts of it. And in this context, when we talk about a Jupyter front end, we're talking about the user interface. So for example, the Jupyter Notebook would be an example of a Jupyter front end. The first thing that you need in such a front end is the ability to, some sort of user interface or UI to compose blocks of code. The user needs a place to type. There needs to be some sort of UI element or control or keyboard shortcut to submit the code to be run by the program. The program then needs a method to run the code, a method to return output back to the user. There needs to be some sort of user interface to view the results. And then the whole process, again, is iterative. So there needs to be a way of repeating this whole process. A great example of a user interface for interactive computing was the original IPython that Fernando talked about today in the keynote that came out in 2001. And again, it provided all these fundamental building blocks for interactive computing. In addition to that, provided things like tab completion, extended syntax, plotting integration. And let's think about how the terminal is a user interface. This is a little bit odd. When we think about user interfaces today, we're thinking about our phones, we're thinking about web applications, but the terminal itself is a user interface. So thinking back to these abstractions for interactive computing, the compose step is done by just typing at the terminal. The submit, you press return. The way IPython is implemented itself in Python looks something roughly like this. The run uses Python's eval function. You evaluate the code, which is a string, in a global and local namespace, both of which are Python dictionaries. The output looks something like this. We're basically printing a string of output to standard out or standard error. The viewing part of that, you're just looking at the terminal, and then the repeat part of it literally is something like a while true with a little bit of extra logic around signal handling and things like that. So again, the terminal is a user interface that implements this idea of interactive computing. But as we all know, there's a lot of challenges to the terminal user interface. So what are the challenges? First, there's no narrative, right? Code without a narrative, as we've learned, is empty of meaning. So and by narrative here, I mean it in a very broad sense of narrative text, documentation, images, visualizations, equations, anything that gives context to the code itself. There's also no memory, and this is very wasteful and frustrating as a user. If you are a user of IPython in the pre-notebook days, you'll remember what your workflow looked like. You'd write code in IPython, but then an external file that you had imported had changed, so you have to quit IPython. That's really a constraint of the Python runtime itself. You restart IPython, and then you start hitting up arrow to cycle back through the lines of, or the blocks of code that you had previously typed. And really advanced IPython users got really good at counting the number of up arrows that you had to press to get to a particular line of code. And that was our version previously of the user interface having memory, and it was really painful. There was also no reproducibility and very limited ability to communicate with others. And so really, no matter what you did in IPython, it was your own private dead end, right? No matter how productive you were. In spite of this, Python, IPython, NumPy, Matplotlib, the whole ecosystem was really revolutionary, even long before the notebook came along. And that's sort of a separate topic outside of this. I'd like to pose the following question. Why is the classic IPython originally and now the Jupyter Notebook so useful in this context of thinking about user interfaces for interactive computing? And I'd like to propose the following. The IPython Jupyter Notebook maintains the full interactive computing workflow while adding these 4 ingredients: narrative, memory, reproducibility, and communication. So here's a screenshot of the first release of the IPython notebook that came out in 2011. It was an extremely primitive piece of software compared to what we have today. Early users will remember that it was a couple of years before you could even change directories in the web application. For years, you had to actually go back, kill the server, change directories at the terminal, and restart it. Amazingly primitive, and yet people still found it useful. And so part of what we're trying to understand is why. Why would such a primitive piece of software by today's standards still be so useful? And so here in orange, you can see these elements required for interactive computing. There's a place here for the user to type code, to compose. Down in the lower left-hand corner, you can see some text describing the keyboard shortcuts. So Shift-Enter. There's a rich output here, and then there's the ability to repeat, right? You can have multiple code cells. In addition to that, you have these other ideas. It's now a file, and so instantly you have a notion of reproducibility, communication, and memory. The user interface, the file, remembers what you've done in previous sessions. You've got equations, you have a narrative, you have images, and other aspects of the memory as well, in the sense that now the computation, the runtime, the kernel as we call it, is separate from the user interface and the document, so you can restart the runtime without losing any of the code that you've typed. That's another form of memory that was built in from the beginning. So where are we with the Jupyter Notebook today in 2017? First of all, I want to talk a bit about successes, places where the software, the community, users have really just done incredibly well. First of all, our users. We have somewhere between 6 to 8 million users. It could be more. It's really difficult for us to get a solid count on this. We did a user experience survey a few years ago. At the time, this is what our user distribution looked like in terms of different backgrounds. Now, I looked last night, and a rough count is that we support over or right around 100 languages. So there's 100 different kernels that have been developed. I suppose there's, in some cases, multiple kernels for a single language, so maybe the number of languages isn't quite that, but many, many languages. And furthermore, increasingly, we're seeing a very, very diverse and international community of users. So here is the Google Analytics traffic for the main website. This is just the Jupyter.org website. And notice the list of countries here. The US is, I suppose not surprisingly, where most of our users are, especially traditionally, but that's only at 30% now. Followed by China, India, UK, Germany, Japan, Canada, Russia, France, and Brazil. And part of what's interesting about this is as we look at this data, what we see is the international audience growing at a staggering pace. I think, I don't remember the exact numbers, but the percentage here represented by China and India has doubled in the last few months. And so it's a really sort of remarkable trend that we're seeing there. We also have a lot of people creating amazing content in notebooks. One sign of this is that GitHub renders Jupyter notebooks in situ. And for example, they have a page where you can look at the trending notebooks on GitHub. And here's a plot, a matplotlib plot that shows the number of public notebooks on GitHub. This has been being maintained by Peter Parente, and I think he tweeted last night that his current count is 1.2 million notebooks. So the growth rate is absolutely spectacular in that respect as well. Part of what's been fun for us is all of you. The amazing community of users that participates in the project in various ways and uses the Jupyter Notebook in ways that we never imagined, honestly. And so we think about this as the emergent behaviors, right? That we have built a few things, and all of you have gone off and built things that are truly spectacular. Here's just a few sort of randomly chosen things. I'll say a few things about this. As Fernando mentioned this morning, a lot of people are starting to write book-length, book-style content with Jupyter Notebooks. Here's one example of Jake Vanderplas's Python Data Science Handbook. There's a number of other O'Reilly books and even other publishers that are doing this. Gene Pattern is a notebook system for bioinformatics, and they've extended the Jupyter Notebook extensively with different cell types for bioinformatics. QuantEcon is a curriculum that consists of Jupyter Notebooks written in Python and in Julia for quantitative economics. We have reproducible academic publications being done in the Jupyter Notebook. Another thing that we're really excited about is data journalism, embracing the Jupyter Notebook. There's a great team of data journalists at BuzzFeed doing this. And then back to our own roots in science. For example, the LIGO collaboration, which has in the last, just over a year ago, I guess, announced the observation of gravitational waves due to black holes colliding. They've got an open science center where they post Jupyter notebooks that fully reproduces all their data analysis, going from the raw data files all the way to the publication-ready files. And so we're really excited to see what all of you are doing as well at this conference. We've also faced challenges, though, and these challenges that we've seen over the last few years really drive how we think about the future. So first of all, the Jupyter Notebook that most of you are using today is built with the web technology of 2011. So at the time, jQuery was used everywhere. The summer of 2011, we actually looked at Bootstrap and decided, you know what, this is really brand new. It's too immature. We probably can't use that. We actually do use Bootstrap in the Classic Notebook. NPM was not being used at all for front-end development, so we're using Require.js. One thing that's really important, though, is that the Python side of the Jupyter Notebook, the kernel architecture, the notebook server, which is all written in Python, all the way back to 2010 has been relatively stable. We've evolved very slowly. This stability of the back end and the Jupyter architecture and network protocols that we've built around that, Kyle is going to talk more about. There's a lot more talks about that here at the conference. But the stability of that has been really important for us being able to break things on the front end and the user interface side. Important features with the Classic Notebook have become really difficult to implement. For example, real-time collaboration, similar to Google Docs, has been difficult because in the Classic Notebook, our models and views are completely welded together in a way that essentially makes this impossible in the Classic Notebook. Other very simple things, like users have been asking for a long time for the ability to collapse source code, to minimize it basically. Even things like that have become difficult because of these emergent behaviors. All of you have been building things, and because of that, things like the DOM structure and the CSS classes in the Classic Jupyter Notebook have essentially become pseudo-public APIs, which makes it really difficult when we can't break if we change those things, we break all the things that you have done. We'll be the first to admit, when we wrote that code for the Classic Jupyter Notebook, we were not thinking it would ever be a public API. And so we never thought about distinguishing between public and private APIs. And that's part of how we got into the difficult situation where building extensions to the Jupyter Notebook, the Classic Notebook, is possible, but it's really painful. From the maintenance perspective, our code base in the Classic Notebook is large enough that you really start to miss static typing. And that's something that we'll talk about in other talks here. There's no dependency injection for runtime dependency resolution. That's really important when you build a system like this, where you want third parties to be able to extend the system dynamically. Also, along the way, we've discovered leaks in the foundation. So for example, this sort of pristine world that we imagine of having a language neutral and front-end neutral message specification and kernel protocol and notebook format, we've discovered leaks in those abstractions. What do I mean by that? That along the way, we found that there was implementation details about the Classic Jupyter Notebook sort of scattered throughout those abstractions. One example is that a library like IPyWidgets is essentially welded to the Classic Jupyter Notebook implementation. Now, it's exciting to note that with recent releases, IPython widgets is no longer welded to the Classic Notebook, and it's able to run in other front ends as well. And we've also discovered and heard from our users that there's other workflows for interactive computing that take these fundamental building blocks and assemble them in different ways. So an example of that would be a user experience that's more like a console. The Qt console of Jupyter is an example of this. So it looks like a terminal, but it has all the rich output that Jupyter supports. Another example would be the type of workflow that you get in an environment like Hydrogen or RStudio, where your source code is really just a standalone Python or R script, but you can somehow select blocks of code and then run them interactively, right? And in the Classic Jupyter Notebook, it's been hard from the user interface perspective to offer and build other workflows like that. And another thing that's important is that these emergent behaviors that I spoke about in the successes section, in this context, because we weren't ready for them, really become a challenge for us. The ecosystem has really become an abundant, fertile, rich garden. At the same time, we've got a code base in the Classic Jupyter front end that's difficult to scale or maintain, to span, to really robustly cover all the usage cases where people are applying that. At this point, I want to bring Kyle Kelley up, and Kyle's going to talk more about how Jupyter front ends are built. And by way of introduction, I wanted to sort of give you context. So when Kyle first showed up on the project, I think it was late 2013, or is that about right?
Oh yeah, 2012.
2012, 2013. One of his first contributions to IPython at the time was that Randall Munroe, who's the author of the XKCD comic, had started to mess with having an XKCD font. And Kyle reached out to him and basically convinced him, will you let IPython be the maintainer of the XKCD font? And so that actually happened. So if you go to the IPython org, you will find the XKCD font. And because of Kyle's work, we are the official maintainer of that font. And a lot of other fun things have happened. So more recently, a member of our community actually wrote some Jupyter notebooks that take the raw, we basically have a PNG or a JPEG of the handwritten characters that Randall Munroe sent to us. And now there's actually Jupyter notebooks that go from that raw image all the way to the font. And goes all the way through the process with kerning and ligatures. And it's quite an amazing bit of work to go from a raw image to an actual usable font like that. With that, I will let Kyle take it away.
Thank you for that introduction. Get this started. All right. So I'm going to change gears a little bit and talk about that protocol and why that matters, like building a front end. And my big takeaway that I want you to have is that you could build a front end for Jupyter, or that you can come and contribute and work on one of the Jupyter front ends. So we've got a simple cell here. Someone's going to do print hey, and then hope to get hey back. And the way the protocol works, it's just this JSON message, and this is not the actual protocol. I'm doing kind of like a simplified version to walk through. Basically, we say we're going to do execution. We say what the code is, and then the kernel responds back and says that it's busy. It's executing that code. It says we have a status message. And then we start getting in a stream of messages that are all just coming in as JSON. So we get the stream, it's on standard out with this hey, and then eventually we're idle because it has nothing else to execute. So if you notice here, there's nothing Python specific. And so like when we talked about some of those implementation details that leak through, like a lot of this stuff is really beautiful and really rich to build those other kernels and to build front ends that work with any of them. Right, and so two types of messages that we've seen so far, just execution status and a stream of standard out, but that's not why most people are using the notebook today. And it's not as simple as just this linear sequence that you're expecting. And so like what happens if you have the longer computation where it's going to sleep and you're going to get a couple different messages, right? So for each of those, right, we're going to hit the status. It's going to be busy, and then each of those individually ends up as standard out, right? And they get flushed in the same way that you do in the terminal, but in this case, it's a little bit richer because you have context of what's what. And then to get to tables, plots, and other rich media, right? How do we get, what is Pandas giving back to us to make it so that we see this here? So if we go ahead and run this code, we'd send over a message from the front end saying that we have this code to run. And then what we get back, and where the true richness of the protocol itself comes back in an execute result or display data. And in there's a field that's just data, which is a mapping from MIME type to some payload. So whether it's text plain or it's text HTML, you're getting that same table, but if you're at the command line, you're getting plain, and if you're in the notebook, you get HTML. Right? And so when we get that HTML payload, we just go ahead and drop it down and plop it into the output itself. But it's not limited to just those simple primitives. We've started establishing richer primitives like GeoJSON here, where you literally are sending over the JSON object and then getting a leaflet map that you can work with and customize. And then for Altair and Vegas and a lot of other libraries that are emitting Vega, we can plot it directly inline. You don't have to install Vega at all because it's built into the notebook itself. It's not in Classic Notebook, but it's in JupyterLab and Interact and Hydrogen. Right, so we had the format. So the next thing that we want to do is figure out how to build a notebook document. And so we've witnessed how we send code. Our code is sent to the runtime, and then what we receive is a front end. Right. So how do we form a notebook, and how do we associate those messages to the cells they originated from? And the key to this for us is message IDs. Like we have this stream of messages, and so we need to associate where an original message came from. So we have a message ID on the one we sent, and then all responses refer to an originating message as the parent. So we'll do those same messages again, but we're going to stick in a new field, which is the message ID, right? And then we're going to initialize our state. We're like, oh, okay, we sent code. So as we build this document, as we work through this, I'm going to do it in kind of like a YAML format on the side here. And so we sent with 0001, and so we got a response that was message ID 0002, and its parent refers to that one message. And so now, as we get that message in, we knew that the status was busy for that message, and we can go ahead and say that the state, at least in the front end, was that it was busy. And then we get our first stream message in, and we can stick that in as an outputs field. Stick in that it's stream, has text, and then what the name is. This is really close to what the actual notebook format looks like, except I'm not doing it in JSON here so that you can read it all in one. We'll get the status that's idle, and then we've got that full final state, right, where we've got the code, the status, and the outputs themselves, right? And then we can go ahead and render that. Since it's like a pure front-end talk, I was like, do I need to tell people? It's like, I'm gonna draw out. And the reality is here we've got an editor that's with CodeMirror, and then we're rendering like what the number is for the input, and then we're also showing the outputs themselves, right? And we append to the DOM and create this overall. It's like a work log that we're building with. So what would an entire notebook structure look like? And like what is the notebook? Right? The notebook is this rolling work log of computations. We're going through it. We have this linear list of cells. And we, as humans, get to work with it non-linearly, but the way that it forms on the page is just this list of cells. Right? And so if we put together a whole bunch of cells all together, right, we can have these text fields for the Markdown, the code, and the outputs, and everything else. Like this is the entire notebook. And you could create your own. Brian was like, don't tell people we could do the format as YAML, but look, it's like the entire notebook is YAML. It's diffable. I didn't say that. Right? And then we can render exactly that same notebook, right? So we've got this one, and then there's the representation of it. Right, so to summarize the notebook, right, we're sending code, we're gonna run that code, get results, plot, yay, that's it. And yeah, that's the notebook. So I've skimmed over this, and if you want more in depth on protocols and formats, there's at least 2 other talks that you should go to. The Jupyter Kernels protocols and the IPython reference implementation talk. That one's tomorrow, I think earlier in the morning. And then the Jupyter Notebook is document talk, which is from structure to application. And that's later in the afternoon tomorrow. And so I think what's important out of the protocols here is that you're not really tied into building just a notebook, right? You can build a front end that actually will work as you can have consoles, you can have, like it is here for JupyterLab, you can have a full-blown notebook, you can have something that's Qt console style, you can build really whatever you want, but with those kind of primitives underneath. And then here's an example. This is Hydrogen. This works inline in Atom. You can select code and run it directly inside of your editor and iterate with it. You're not getting a notebook at the end, but for a lot of people, this is literally what they want because they only want to work with a script. They don't want to work with a notebook. I end up doing a lot of experimentation here because I just want a scratch space. And like I was saying about kind of experimentation, oh, is this loading? Oh, there we go. So Hydrogen introduced a watch expressions concept where they're storing the outputs. Instead of creating a cell, it's effectively every time you run code, it reruns this little section of code and then stores the output. And then you can scroll through that output to see how it changed. So you can kind of play with a parameter and go through it. This is what they call watch expressions. When I first saw this, I was like, oh, this is silly. You should like build it with widgets and everything else. And then I was like, oh, this is simple. Like I don't have to do much. I can literally work in any language, and I get this. And it's just because of the Jupyter protocol. There we go. And then nteract itself is another front end. It's built upon Electron, and it's really just the classic notebook, stripped down, trying to be as minimal as possible, trying to reach an audience of primarily analysts and people that just generally kind of want this like simpler UI to work with it and just work with the files themselves. On some level, it's not any different than the Jupyter notebook. It's an opinionated stance on how to build it. And then one other, and then I'm going to skip to the end here as we're running out, is Rodeo. And so this is similar to JupyterLab, but it's as a desktop app, and they have their own kind of way of showing plots and tables and everything else kind of inline. So it's like they built an RStudio, but on top of the Jupyter protocols. And they had no involvement from us. They were able to just build it themselves. So anything I said, you can build it too. So if you want some more in-depth talks on alternative front ends, Kaggle built their own kind of front end. They call it Kernels for how they interact with their notebooks. It's got a good sharing platform. And then the JupyterLab talk, if you stick around in this room, that'll be here as well. And that's it. Mandatory quick.
Still live here. Kyle forgot to mention, he's also giving another talk today at 2:40, I think, on his work at Netflix, supporting users there who are doing a lot of work with notebooks. So check out that talk as well.
Cool. Somebody have questions? We got, what, 3 minutes?
So I liked Wes's talk about Apache Arrow and how they're trying to sort of abstract all getting your data and analyzing it so that the code is really just a user interface. Have you thought about that for the other end, for the outputs, the graphs, the charts?
I'd certainly be happy to talk about that.
Can you repeat?
What's that again? Oh, so the question was, have we thought about using like Apache Arrow in the front end, kind of as a data interchange format, as well as what we're going to show on the outputs? So Arrow itself isn't binary, and if you're used to working with your images, you might know that they're base 64 encoded images that end up in the notebook. And so one possible option is that one could just send that over as like a base 64 encoded blob, and they'd end up in the notebook, but it would get really big. My hope, so what we didn't cover on the protocols is that there's actually like a binary section of the protocol that we could put stuff through. And I'm really hoping that maybe we could have a data protocol that, or at least a way for us to kind of like pass data around, or where we might stage data locally, where it wouldn't be part of the notebook document, but we acknowledge it, especially to work between different kernels. But no active work, but I'm really interested in it. So the question was, do the other front ends support like the IPython widgets and other third-party pieces? So JupyterLab does.
Yeah.
That's about it.
Yeah. So, so I can comment a little more. So the widgets team has been working really hard to document their own message specification. In terms of, they send JSON messages over the channels that we've set up. And the challenge is that traditionally there was no real documentation about the format of those messages. And that made it really difficult for other front ends to implement that part of the message spec. So they have been definitely working on that. It's a work in progress. Our hope, though, is that we'll get to the point where there's a standardized message specification for both front ends and for kernels to implement widgets.
Because the other thing that I've run into in production is as the widgets change, especially on the front end side, not all the kernels have. And so like the R kernel had support for it. And as soon as widgets put out a new release, the R kernel was broken for us. And I was like, okay, we need to revert this and just not support widgets then at that point. But we really want that to stabilize as much as possible. Question was, how are these messages consumed on the client side? So on all the web front ends, they come on over WebSockets. At least on nteract and Hydrogen, it goes directly over 0MQ. And then the JupyterLab app is actually spinning up a notebook server, so that one's over WebSockets too. Question in the back?
Yeah, so the question is asking about the so-called COM channel that we have. The COM channel is basically a namespaced way for third parties to send messages over our network protocol. And the question is, do we view that third parties using the COM channel as sort of undesired or an embraced way of extending the platform? And I would say, in general, that's exactly what it's for, is for extensibility, with one caveat, and that is that our hope and our vision is that everyone using that would define a JSON schema so that other people know precisely what is being sent over the channel. That I think is our
and your own fellow engineers, when eventually
Yes.
you break yourself.
Yeah. So yeah, basically, versioned JSON schema is something that we are thinking a lot about across the entire code base.
And then I would say another thing, and why you want to try to get it documented, and like once you start working on comms, maybe you've prototyped something, we should try to bring those more into like the main pieces. Like, you know, if it's something that's uniquely useful, like I think there are like 12 different implementations of custom Spark UI for your front ends. And like, I would like more of those to merge as much as possible. Like, you know, they can be diverse however they want, but at the very least, like the out of the box experience in Jupyter should be much better. So, yeah.
So the question here is, how much work is involved to migrate classic notebook extensions to JupyterLab? It really depends on what it is. In some cases, it's not bad at all. In other cases, it would be a huge amount of work. If you want to come to our JupyterLab talk right after this, you can learn a bit more about that stuff, and we're available to
And if
chat
your
more.
question's not answered there are sprints on Saturday in which you can sprint exactly on that problem.
With all of these different clients, you see JupyterLab going forward to be more of a standard and the protocols that we can use, widgets, types, and be more of a standard and JupyterLab being an implementation and that approach so that with different domains, different users, different skill sets, you know, and so on. Is that the direction, or is it more of we're going to build this really great tool that has all kinds of things in it, and we allow people to customize or have their own implementation, but their
Yeah, so the question is, are we shifting our thinking towards the Jupyter architecture being the standard, and the Jupyter, like the Jupyter official front ends being one amongst many implementations, or sort of how are we balancing that? I think our perspective is that our user community is big enough and growing fast enough that there's no way our sort of core Jupyter developer team can support all of those users and all of those usage cases. It is not possible. And so our goal is to build the platform in a way that all of you and other people can build things for all those different usage cases, and at the same time balance that with us maintaining a core experience that serves a decent number of users. That sort of the traditional users of Jupyter really are sort of in the classic scientific computing, research, data science, machine learning type of space. Kyle, I think, has a great perspective on this at Netflix, as he supports a very wide range of users. So I don't know if you want to add to that.
Yeah, I'm definitely noticing, like we have to support multiple front ends. Like there are people that use notebooks kind of as templates where they've effectively written out a query that they're going to use. And it's kind of like a dashboard, but they really need to change it, and they want to like fork over from it. But if they see too much going on the screen, they're like, I'm not using this tool. Like I'm going to go to my, you know, whatever I want to be, or be in Tableau or whatever else. So that's, yeah. So we actually, and like we deploy multiple front ends now, so.
I think we're out of time. Please come up afterwards. We can answer more questions. We also have a Jupyter booth in the sponsor pavilion there. It's at the far end, so please drop by to chat with Kyle, myself, or other Jupyter developers. And with that, I think we'll finish.